It's good to be here again. I see some familiar faces, and it's always good to be back and talk to you about the product directions. So you did already introduce some parts of it. I'd like to go a little bit deeper, as long as. Thank you. Good point. So the other button. So Judith already mentioned that we have a company mission. And here in this sentence, I'd like to point out two things. One is that we'd like to be part of the discovery that you have in your companies, and we'd like to be more of a partner than just a vendor of software solutions. And the other one is about the word biology. And I might clarify that a little bit later on. That word means that certainly we see the trends of the shift that happens right now within the pharma industry, and that more and more biologics are coming into the picture, and not only small molecules anymore. We cannot avoid that trend, and we need to take the first steps so that we can catch up with it. Speaking of trends, first I'd like to go through some trends, what we see in the industry. I will speak about data. I will speak about outsourcing and collaborations. I will speak about new domains, namely biologics. I will also mention changes in user habits and their different needs. And there cannot be a presentation without AI and ML. So about data. Data is everywhere. Data is something that we are more and more focused on. And we've heard it so many times that the algorithms, even within cheminformatics, are more and more of a commodity, and the data is the key, and the data is what you have in focus during your research. But it comes in different layers. So if you think about cheminformatics, in the center, certainly, there's typically a structure or of small molecule data. Then we have a bunch of molecular properties that typically can be collected in a flat data table. Then we end up eventually with more complex relational data structures, and we get lost in the forest of different tables in our database. So that at the end of the day, we end up with an even more increased complexity of the unstructured data, all the documents that you can see around in your company, all the raw data collected by your instruments. So it's challenging. It's also challenging because you have many things in focus. You have to manage the data. You have to migrate from legacy systems. You have to deal with the unstructured data and all the data lakes that appear everywhere. And fair is also a buzzword that we keep hearing now for many years to have data that's actually reusable. In terms of outsourcing, there's an impressive number in that sentence. So last year it was 50 billion, the CRO market, and it's assumed to be around 90 by 2028. I know it's just a prediction still. It's something that we cannot deny, that more and more of the research, more and more of the IT is essentially outsourced, and the collaborations themselves become more important. The collaborations among different parties, the collaborations that enable us to come up with solutions that one company couldn't target by itself. Also, in terms of new domains, the biologics that I already mentioned, it represents a more and more substantial portion of the newly approved drugs. We cannot deny that fact. And it comes in various different forms. Some of them are much more close to the typical small molecule representation, while others, live cells, are just way off at the other end of the spectrum. Also, we see that we have a new generation of scientists starting in research. They have different expectations. Cloud is not really an alien thing anymore. It's something that they would expect to use. Touch devices are obviously there in our lives, and touch devices are more and more there in the instrument vendors' approach as well. So yes, it's changing when it comes to user habits. And last but not least, for the AI, there's billions going into AI research, and we're still struggling with finding its appropriate place. We keep complaining about the fact that there's not enough data in the medicinal chemistry research because AI is much more suited for cases where you have essentially a big data scenario, and medicinal chemistry is not a big data scenario. So, what should we do? How do we react to these changes? First of all, as Judith said, we've been known for some smart fundamental chemistry tools. We will keep improving that. We will support that in the long run as well. And we'll make sure that those tools that we're known for, like all the different JChem flavors for structure search, the different versions of Marvin, which we will consolidate into a single solution in the future for drawing, the different calculations, predictions, will still stay in focus. At the same time, on the top of those smart tools, we will build more and more end-user-facing solutions. End-user-facing solutions for medicinal chemistry design or for synthetic chemistry. So at the end of the day, naturally, if we have all these tools and integrated solutions, we need to provide them somehow, and that somehow is the Chemaxon Cloud. They are going to be delivered on a cloud platform, and certainly not only by themselves, certainly supported by custom development whenever you need it. We are eager to see more and more technological partnerships, and of course, training and support is always important. So what does that mean? What does the cloud mean? And I know that that the platform is one of the one of the overused words the same way as AI itself. On platform, we mean that we have different components for different specific tasks that you want to do during your work. We have plenty of them. Some of them can be, all of them provide the so-called toolkit-like functionality. Some of them, at the end of the day, can be put together into solutions that cover larger workflows, and certainly more of those can exist. Beneath all of these, we will have a core and product platform, where core means essentially all the basics, all the infrastructure, all the fundamental concepts that you need to have. And the product platform means essentially a generic layer which enables us to build easier new products on the top of that platform. All of these will be joined by some sort of administration activities, and then at the end of the day, you end up with the client-facing user interface that you can expose to the end users. Let it be more advanced end users for the configuration part, or the researchers themselves. There's also a client-facing API so that you can integrate it at the end of the day in your existing environments. And certainly, user experience and security will join the pack here. And at the end of the day, as Judith said, we will provide it on AWS. So we call it a platform because, first of all, It's designed to be very modular, but consistent at the same time in many different ways. In terms of user experience, in terms of usability, it's consistent in terms of design principles, it's consistent in terms of component interaction and how you can integrate it into your systems. Security, obviously, and we'll keep using it to build more and more products that target specific workflows on the top of that. And last but not least, it's something that should be extended by the customers as well, in case they need it integrated into their systems. So the major benefits, as Judith already mentioned most of them, it should be easy to use, coherent UI, new features available instantly. In terms of operations, the ease of integration, the quick deployment should be focused, and the lower maintenance costs on both sides. And in terms of security, it should provide a reliable technological foundation, and at the same time, all the state-of-the-art security and scalability and performance benefits. So at the very beginning, we'll deal with two workflows, one targeting the design of new molecules and the other one a synthetic chemistry approach. And how we imagine it to work, that's something that I'd like to summarize for you in a short video. So that's what I mean when we talk about consistent and user experience and about coverage. The next steps when it comes to that platform and how we roll it out. So, planned timeline. We're working at the moment on the synthetic chemistry solution, which is supposed to be the story of the first quarter of 2023. Then we'll focus on the bioregistration and some calculators. Then, in the second half of the year, we're focused on providing Design Hub, Marvin Pro as a sketcher, and the chemical registration on that platform. So, as Judith said, the fact that we focus on such a future platform doesn't mean that we completely abandon the existing solutions. We do have a number of products. At the moment, it's around 50. Those 50 products fall into different categories. Some of them dealing with chemical representation, others dealing with search and data management in general, others dealing with discovery and design, some more chemistry in documents, And last but not least, about shipment and compliance. In chemical representation, we have new things. Zsolt will have a presentation about our drawing and rendering approach. Also, we have introduced this year a new file format called Sixon, which is a JSON-based file format for easier REST API integrations. In terms of search and data management, we provide structure search features, we provide chemical registration, and as a new thing, we will introduce registration for different modalities in biologics, starting with different oligopeptides, oligonucleotides, ADCs, and then later on expanding in terms of modality types. In terms of discovery and design, we have chemical calculations and different property predictions. You will hear a presentation on how we imagine property predictions to be trained. Dora will have a sneak peek in that, and some Marcus tools as well. In terms of chemistry and documents, we do have chemical naming tools. We do have document creation and handling. JChem for Office is one of the examples here. And again, the Marcus tools. And in terms of shipment and compliance, we have the compliance checker, which is extended with the HTS code assignment for the tariff codes. So, as a summary, I'd like to emphasize again that we will keep building on those strong chemistry foundations, and we will build the solutions on the top of those toolkits that we've had. We will provide our future solutions on this cloud platform that I shared with you, and at the same time, our existing solutions will be continued to be maintained and developed further. With that, I'd like to thank you for your attention, and I'm happy to answer any questions either now or in the coffee breaks. Thank you.
So what kind of plugins do you provide for visualization of the molecular models? And is this just the K-Maxon tool, or?
On molecule models, you mean the 3D?
You showed a picture on the top right-hand side.
Yeah.
So what kind of an interface is that?
So that 3D model is one of the plugins of Design Hub that you'll see later on in the presentation in the afternoon, I believe. And that's our own visualization plugin. And it consumes essentially any PDB that you can get out of your favorite docking software, and it can visualize it along with the ligand. You can interact with it in the typical 3D fashion. So it's not someone else's 3D visualizer embedded there, but it's our own visualizer that can simply open up your result files. We do not deal with the docking itself. So the docking itself is still supposed to happen in a different application, but Design Hub is essentially really extensible. So you can plug in anything that you have at the moment.
Essentially, what I was trying to understand is, I mean, say popular visualization tools like say PyMol or say MolSoft ICM, for example, whether those can be kind of plugged in or integrated.
At the moment, it is our own rendering, but we can discuss how PyMol could take a place there. Yeah, sure.
Can you elaborate on chemical registration?
Yes.
Can you elaborate a bit on that?
On chemical registration, any news? So you'll see later on in my second presentation in the afternoon how that chemical registration is being rethought right now, so that we can use all those cloud-native technologies that exist on AWS, because we intend to make it much more performant than what you see right now. I mean, we know its limitations, and at the same time, we see the increasing need for registering not only millions, but at some point tens or hundreds of millions, and in some cases billions of structures. I mean, look at the Anamin DB, how it looks like. Nowadays, it's close to 5 billion. So at some point we need to deal with the ability to keep them organized, to keep those databases organized the same way.
Amazon is going to have its own ID first.
Sorry?
Amazon will going to get its own ID for the company.
I mean, chemical registration by default is targeting our customers' own compound data set. So we do not want to replace any existing ID that you have out there in public data sets, but we intend to keep all the data sets that you have to use in your work as organized and as standardized as possible, so that there are no unintended duplicates or weird structures in there.
Yeah, if I just may add, so the ID that you generate is completely customizable as per your business logic. So it is not a Chemexon generated Chemexon notation. So it is completely based on, let's say for example, if you're working for molecular connection, it can be MC_01_ whatever. So there's a particular syntax in which you can create your own customizable ID. So but then every ID that will be generated will follow the same logic, so that it is standardized.
Thanks.
Yeah, can I ask? Manoranjan, you want to ask?
Yeah, Dr. Sani, go ahead.
So yeah, this was a very good start and very good presentation. So my question is, you did mention about one of the slide where you're showing a pipeline which is still in progress, right? The ELN system followed by registration. Is this a cloud-based system or it's a local installation?
It's a cloud-based system. Everything that we do right now, the new stuff, is cloud-based.
So if I want, as per his last question, so we have our own data sets, we have our own compound libraries, which are already being for the ancestral things, right? It's very old, so it can be integrated into this system efficiently without losing any critical information.
Yes, that's our intent. And actually, it doesn't really depend on whether it's cloud or not cloud, because what we experience in case of migrations to our compound registration, you would need to migrate the data anyways. So it's not that you have your data set somewhere, you just point your application to that database and keep using it, because there needs to be a cleanup that's consistent with the configured rules that you set up. Otherwise, later on, you will face unintended issues. So that data cleaning step has to be there, and that data cleaning step will work the same way in the cloud environments as in case of the on-prem ones.
Yeah, Dr. Monroe, we can take your question.
Hi, good talk. I had a question. So in your DMTA cycle, so design and analysis is something close to our heart in terms of computations.
Yep.
So what are the technologies and innovations you bring in those two aspects, considering that Chemexon has a rich experience of chemoinformatics?
Yes, thank you for the question. So first of all, you could see even in my representation that we keep focusing on the design and make parts, and certainly some of the analysis. You cannot really split between the design and analysis. It's always the result of an analysis that you have designed. And that's one of the things that we've been focusing on for a while now, how to bring the necessary amount of analysis into your future design. Because at the end of the day, your researchers, all those medicinal chemists, would need to focus on what's next, the next big hit, the next compound, and we intend to make it as easy as possible for them so that they do not have to dig into different analysis software and then think about the design. In terms of specific innovations, in Design Hub, one of the key features that you'll see later on in one of the presentations is the collaborative design. And on collaborative, I do not mean that people draw something together. On collaborative, I mean that all the efforts that go into research are actually efforts of a larger team. You need to bring together the team, you need to keep that team organized, and you need to make sure that they actually can prioritize together for everyone providing their own perspective. In terms of the technological advancement, I mean, we've been dealing with search for many, many, many years now, and we intend to put live chemistry searches wherever possible, so that your ELN, let's say, does not become a large lake of data that you captured and you never retrieve. It's intended to be used. So, and using it means that you can easily access it. You can access it anytime, and you can essentially serve the chemists themselves with the data when they're designing new experiments. These are the key things that we intend to focus on, and whatever technological changes need to happen for that.
Thank you. One follow-up question would be that, so it's easier to organize and analyze our in-house data because we know in and out of it. But there are rich literature out there, be it patents or publications, and every program that you work on, some angle of literature is always involved. And we struggle and spend a lot of time in bringing that back to the platform, any platform that we use.
Mm-hmm.
What are the things that ChemExchange is doing to actually bring the literature information back to your platform in an organized way?
So in terms of literature data and documents in general, you might know that we have tools like ChemCurator and document structure in general that are dealing with the either automated or sort of manual indexing of those data and organization of those structures. We intend to have them more and more integrated into the design process where they fit, and make sure that you have a similar functionality or you have a patent creation functionality where you need that. It shouldn't necessarily be a separate tool. It should happen where there's a need for that.